And okay. Okay, section 5. Factoring x squared plus bx plus c. Okay, a couple things in this title. First off, we are going to be continuing on with this concept of factoring. Just to remind you guys again, what does factoring mean? Factoring is the inverse operation of distribution. Okay, so in the first couple sections that we covered in this unit, in section 2 and section 3, namely, in section 2 and section 3, we dealt with multiplying polynomials. Okay, similar to what we start with here, where I have, in this case, two binomials multiplied by each other. And our process was to distribute through multiplication each object throughout that parentheses, and then we would collect like terms at the very end to get some result. Now, this one is complicated looking on purpose, and I'm going to talk more about that in a minute. But basically, in section 2 and section 3, we started with these parentheses, these polynomials multiplied by each other. We would distribute, collect like terms, and get a sentence polynomial result, however long it may be. So factoring, again, just to remind you, goes the opposite direction. In other words, we're going to start with these polynomials. Okay, we're going to start with polynomials, and we're going to work our way backwards so that we have it broken up into these parentheses. We introduced that concept in section 4, the idea of factoring, or what to do with factors and why it was important. And I'll remind you that the main function of why we want to have certain polynomials factored has to do with what's called the zero product property. Basically, when it's factored, we have a series of parentheses multiplied by each other. In this case, there are only 2, but you could have a lot more. But what is valuable there for the zero product property is that if any one of the parentheses in however long the string is, if any one of the parentheses is 0, then the whole thing would be 0. And that's valuable when I need to solve for the variables. And that's what section 4 was about, was solving these polynomials for x. Okay, so again, factoring deals with, I'm given some polynomial, work it back into this factored parentheses form, and that can be useful for solving the polynomial. But for right now, we're just going to focus on how to get back to this point. Okay, and the other part of this title, the x squared plus bx plus c, just refers to the kind of the style of polynomial you'll be seeing. It's not going to be longer than this in this section. It's going to start with an x squared. In tomorrow's section, when we get into section 6, we'll talk about what to do if there is some coefficient, some number multiplied by x squared, because you will come across that as well. But for right now, we're going to keep it this basic. Okay. All right. So let's start with this first example, because this is going to kind of, again, break down how we're going to go about this factoring method. In section 4, we briefly introduced the most basic form of factoring, which basically says, if in a given polynomial, if each term has something in common, I can factor that something out. Okay, and what you're going to typically see in this section is a bunch of polynomials where they don't have anything in common, and so that step is we don't need to do. We can't do it, right? That doesn't mean that it can't be done in the future. Just that's still something we look for first, but in these cases, we're not going to have to do that step. But then what do I do once I get to this polynomial and I'm going to be asked to factor? So in order to answer that, I'm going to back up a second to kind of what we did in section 2 and section 3. So in section 2 and section 3, we started with polynomial multiplication. We were given some polynomial multiplied by some other one. And our process in order to distribute and combine these was to take each term in the first parentheses and multiply it throughout the next parentheses. And then once I'm done with that object, then I move over to the next one. Okay. So what do the P and the Q represent in this example here? Well, essentially they represent anything. Okay. Any two values that I get here, any two numbers or variables or whatever. And so this is going to look a little more complicated than most other ones, mostly just to demonstrate something, and I'll talk about that in just a moment. So when I go through the process of distributing and collecting like terms right here, I'd start with x and multiply it throughout this parenthesis. So x times x gives me x squared. X times the q gives me qx. Then I'm done with the x, so I move on to the p. P times the x gives me px. and then P times Q gives me PQ. Again, P and Q can be anything. So had this been like a +2 and that one a -3, then the numbers would have changed accordingly. But in this case, P and Q will represent anything. So when I get to this part, this is the distribution part of the problem. Now what I'm going to do is I'm going to combine like terms. And these two middle terms, from what we've seen in section 2 and section 3, these two middle terms, since they both have an x in them, these two can combine. Because again, P and Q won't be P and Q. There'll be some numbers. And I just combine them. I combine them through addition or subtraction or whatever. In this case, addition. And what I would end up with is when I went through my distribution, P times Q gave me this P times Q last number, whatever that number was. Again, these will be actual numbers, not P and Q. And so that didn't have any other like terms, so that stayed PQ at the very end. The one that was a little more interesting, the one that had like terms, I'm combining the P and Q together through addition. And here's the main point with why we went through that process. Whatever these two values were, whatever they may be, whether they're positive or negative, whatever, you're going to get whole numbers here, positive or negative. Whatever they were, they ultimately multiply together to give me this last term, this last coefficient. But they also add together to give me this middle coefficient. This is ultimately going to be the main punchline for this entire section. And it's a very abstract punchline, so please pay attention. We're ultimately going to start with a polynomial like this. Now, these will be numbers instead, and you'll see that in a minute. They'll be numbers instead. But you're going to get some polynomial like this, a trinomial, in fact. And you're going to be asked to factor it so that it looks back like this. And so the structure we're going to have is it's going to be in two parentheses, and then x at the front of both of those parentheses. That's why we're going to get an x squared. Okay. But then we're going to have to basically fill in whatever these two values are. And again, the punchline of this entire section is this. Whatever these two values are, whatever two numbers, they're going to have multiplied to make the last coefficient. But they're also going to have added in some way, shape, or form to give me this middle coefficient. Multiplied, added. This ends up being the punchline here. So let's apply this to an example. Here we're given the polynomial x squared plus 10x plus 16. Now this is going to be pretty typical of what you'll see in the section's assignment as well as in the chapter 2 test. You'll be given some trinomial like this. Again, this structure. Right? B and C can be anything, and you'll see that as we go along. But it'll start with an x squared. It'll be a 3-term polynomial. Okay? And it's going to ask you to factor the given polynomial. So let me go back to the punchline here. I'm going to be asking what multiplies to make this last term. There are going to be two numbers that multiply to make this last term. And there are actually lots of numbers that multiply to make 16. I'll deal with that in a second. But I'm also going to be asking what two numbers multiply to make this last guy, but also the same two numbers add in some way to make this middle guy. Okay? So here becomes the driving question. You'll see this in my solutions as well. But this becomes a number puzzle. It's a little less mathematics and more just abstract thought. And what I mean by that is it becomes a simple game once you get used to it of just like figuring out what numbers multiply to make a given number. But I have to choose of those many options, which also combine in some way to make this middle one. Okay, it's a puzzle, right? And so in this case, for this specific example, I'm specifically asking which two numbers multiply to make positive 16, but also add in some way to make positive 10. Where did those two numbers come from? The 16, again, is the last term here, the last coefficient. The 10 is the middle coefficient, positive 10. Okay, so to answer this first question, there are actually lots of options. Right? And so in this case, what numbers multiply to make positive 16? There are several options. 16 and 1 can multiply to make 16, but also be aware that -1 and -16 also multiply together to give me positive 16. 4 and 4 multiply together to give me 16, but also -4 and -4. And then finally, 2 and 8 multiply to give me 16, also -2 and -8. So I had lots of options for this first question. What will specify the specific combination will be the answer to the next question. Not only do the two numbers have to multiply to give me this result, but also they need to add together to give me this result, that positive 10 from the middle term, middle coefficient. So 16 and 1 can multiply together to give me 16, but they can't combine in any way to give me 10, whether I'm adding or subtracting. 4 and 4 multiply to make 16, but there's no way I can combine 4 and 4 together, addition or subtraction, and give me positive 10. But 2 and 8, and that's ultimately the answer here, 2 and 8 can multiply together to give me 16. And I can combine 2 and 8 in some way to give me positive 10 through addition. Okay? And so more specifically, the answer here is positive 2 and positive 8. When I multiply those two numbers together, I get positive 16. And when I add those two numbers together, positive 2 plus positive 8, I get positive 10. So it's the solution to that puzzle. Well, so what? What do I do with those two numbers once I've solved the puzzle? They multiply together to give me that last term. They add together to give me that middle term. Great. So what now? These end up filling in the structure here. So where did this structure come from? Up here. Again, for any of these kind of trinomials, the ones that are x squared plus bx plus c, okay? Anything like that can be factored in some way back to this spot right here. And actually, let me qualify that. There are exceptions to that rule. There are some problems that are not factorable. We'll deal with those in the future. For right now, just in this section, they will all be factorable. But this is the structure I'm going to build into. So I basically just need to figure out what P is, what Q is. Well, in this example here, P and Q are positive 2 and positive 8. And I get x plus 2 times x plus 8. I went into a lot of detail getting to this spot. It'll go a lot faster once you get used to it. But just to kind of confirm, if I were to go through distribution and collection of like terms, I should get right back here. Because again, these are inverse operations of each other. If I were to start with a polynomial like this and be asked to factor it, I should get back to these parentheses. In section 2 and section 3, I started with these parentheses. It said to multiply together or find the product, and I would get back to this result. They undo each other. But that also means that these are the same exact thing. So in this case, if I were to distribute and collect like terms, I do x times x. That gives me x squared. X times positive 8 is 8x. But then the positive 2 times x is also positive 2x. And the 8x and positive 2x would combine to give me 10x. And finally, the positive 2 times positive 8 would get me to the positive 16. If I were to distribute this, I'd get right back here. If I were to factor this, I get to here. Okay, so let's see this in a couple of examples. Okay, and I'll talk about what's going on in the margin tomorrow. This will be more applicable to the types of polynomials we'll deal with tomorrow. It's more important when there's a coefficient in front of the x squared for this process. So I'll address that tomorrow. For right now, this question, this puzzle is enough for these problems. So we'll do this a little bit faster now. Again, this is how it's going to be phrased. It's going to tell you to factor the given polynomial. There are no common factors between these three terms. Between these two, yes, but there's nothing here to be in common with these two guys. Right? But you're going to be asked to factor this trinomial. So here's the game. What two numbers multiply to make the last term, positive 12, but also add in some way to give me this middle term, the negative 8. And I write it out here. You don't need to write this out every time in your notes. I do it mostly to kind of help direct your line of thought. But in this case, what two numbers multiply to give me 12 that also add to make a negative 8, that combine in some way to give me a negative 8. All right, so let me demonstrate this on the whiteboard. So here we're given x squared minus 8x and then plus 12. This is something commonly that you'll be seeing in this section, what you'll see on a chapter 2 test, and it's going to simply say factor. immediately, here's what you should do. You know it's going to go into this structure. Immediately. You know it's going to go into this structure. Now, for the record, again, not every polynomial, not every trinomial is factorable. And what I mean by that, there's no combination. Basically, there's the answer to the question, what multiplies to make the last term that also adds to make the middle term. Basically, the answer is there is no combination. Okay, we're going to deal with those in the future. For right now, in this section, they'll all be factorable. And so in this section, when you come across this, an x squared plus bx plus c situation, and it asks you to factor, this is what you're going to be building into. You're going to get two parentheses, two binomials that will multiply by each other. X will be at the start of both. The reason why, the x times the x will give me the x squared. I don't have to worry about anything else because there's no other number in front. Again, tomorrow in section 6, we'll deal with, well, what happens if there is a number in front? That will affect what the result will be, but we'll deal with that tomorrow. So I know I'm going to be in this result. And so what we learned at the beginning of these notes was that whatever these two values are, filling in the blanks, whatever these two values are, they need to multiply together in some way to give me positive 12. And they need to add together in some way that gives me negative 8. And so here's kind of the long way to do this problem. Okay. This is the long way. You don't have to do this. For some people, it is comforting to be able to do this, where they were like, they would first start with like the factors that make this last number. So for instance here, how can I multiply numbers together to give me positive 12? Well, there are lots of combinations. Okay. 12 and 1. And for the record, negative 12 and negative 1 can also multiply together to give me positive 12. Okay. I could also do 6 times 2. 6 times 2 gives me positive 12. Also, negative 6 times negative 2 gives me positive 12. And finally, 4 times 3, or negative 4 times negative 3. Any of these combinations will give me 12. But only one of these pairings will add in some way that give me a negative 8. And so particularly early on with doing these problems, some students like to make their little list of the possible factors for their last term so that they can actually just visually look at these. And then what my suggestion is once you have this list, and this list in some cases can be a lot longer or even shorter. But in this case, I have 3 different pairing options. And then what I would do is I would look at each and ask myself, is there any way that they can combine to make this middle number? There is no way to combine a 12 and a 1 through addition or subtraction that gives me a negative 8. So that one is immediately eliminated from contention. 4 and 3. 4 and 3 cannot combine through addition or subtraction to give me negative 8 at all. 4 plus 3 gives me positive 7. A negative 4 minus 3 gives me negative 7. That's as close as it gets, but it's not going to be negative 8. So this one is also out of contention. 6 and 2, as many of you have probably realized by now, 6 and 2 can combine to give me a negative 8. But 6 plus 2 is positive 8. So how do I get to a negative 8? If both of these are negative. And is that possible? Does a negative 6 times a negative 2 give me positive 12? Yes, because the negatives cancel. And so to answer this question right here, what two numbers multiply to give me positive 12, but also add to make negative 8? Negative 6 and negative 2. That negative 6 and negative 2 are what go into that structure. All right, and this is my factored form of that trinomial. And you don't need to do this part. This is just to confirm our result. If I were to distribute and collect like terms that have x times x, that's x squared. X times a negative 2 is negative 2x. Done with the x, move on to the negative 6. Negative 6 times x is negative 6x. And then finally, negative 6 times negative 2 gives me the positive 12 because the negatives cancel. And as you can see, these two middle terms combined will give me the negative 8x. And so this is confirmed that this is my factored form. And again, just to confirm why we did what we did, these two numbers multiplying together to give me this last term is because when I distribute this ultimately, I end up with that being multiplied together. Why did these have to add together to make this? Because when I ultimately do x times each of the numbers on the outside and then on the inside here, I'm going to get common terms. And when I combine these common terms, they need to combine to make this middle guy. So they end up adding together. Now the -2 plus -6 became more negative. That's why it stayed negative there. But what you can see is that by distributing, I get right back to my result, which is what should happen. Technically, this is just a way of checking your work, though. All right, let's do one more example. Get back to our notes real quick. Our last example here, and you'll notice that the reason I chose these two examples is because there was a negative involved in different kind of locations, and that will kind of affect which pieces are negative. I didn't want to focus on that too much, but because ultimately the process is the same. You're going to be asked to factor again. You're going to be given some trinomial. There is no common factor between any of these terms. The reason I check that first is because if there is something in common between all three, I can divide that common term out first, and then maybe I get to this result, and now I can continue on as normal. But the name of the game is the same. What multiplies to make this last term, but also adds together to make this middle term. What multiplies to make -21, but also adds together to make a +4. Okay, so back to the whiteboard. Okay, so in this case, we were given x squared plus 4x minus 21. And we're asked to factor. So again, the very first thing I would do, I know I need to factor it into this format. X is at the front of my two parentheses because again, x times x, when I ultimately distribute both of these together, x times x will give you my x squared. So now I need to figure out what these two missing pieces are. And whatever these two missing pieces are, have to multiply together to give me this last number, this -21, but also combine in some way through addition or subtraction to give me this middle term, the +4. And so again, what may be comforting to some of you, especially early on, will be to first list out your factors for this last guy. Now this one will be a little bit shorter list than the other ones. So what numbers multiply to give me a -21? Well, 1 and 21 can multiply together to give me 21. And since it's negative, one of these two guys has to be negative. It doesn't matter which, but only one of them will be negative. It could be -1 times 21, or it could be 1 times a -21. Either way, I'll get this result. So usually what I do is I just list out the factors as regular numbers, and then I figure out which ones have to be negative based on this middle guy. Okay. But another combination can do it, and that's 3 times 7. And that's actually it. These are the only two combinations. Okay, so these are the only two combinations. Again, because it's negative, one of these numbers will have to be negative. The other one will have to be positive. It's the only one I get a negative product. Okay, but then the next question I ask is, which combination of these numbers will combine in some way to give me a +4? Now this one may be a little more obvious, but I'll go ahead and work through it anyway. 1 and 21, there is no way to add or subtract these numbers together to get 4. Can't happen. 21 is just too big. It's too far apart from 1. Yeah, I'm either going to get something way negative or way positive, right? But with 3 and 7, I can combine these two in some way to get to 4. Namely, if I subtract the 3 from 7. And that ends up being the main point right there, right? I can combine these two numbers to give me +4. So obviously this will be the combination I go with. 1 and 21 couldn't. So 3 and 7 are going to be my combo. But again, back to the original number right here, they have to multiply to give me a -21. So one of these two numbers has to be negative. But which one? And that will be determined by this middle number. Because it's a +4, the 7 is going to be positive. The 3 is negative because it's 7 minus 3, or 7 plus a negative 3 that's going to give me this positive 4 result. Had I gotten the wrong one, I would have had a minus 4 result. So for instance, if I had a positive 3 and negative 7, 3 plus a negative 7 is negative 4. Well, that's a positive 4, so that would be wrong. So in this case, again, the 3 has to be negative. The smaller number has to be negative because I get a positive result when I combine them. And so positive 7 and negative 3, just to confirm, positive 7 times a negative 3 gives me negative 21. Again, since 1 is negative, that's why I get a negative result. Then when I add these two together, I get a positive 4 in the middle because the positive number was bigger. Okay. So a lot of moving pieces in these problems, but that's the game you ultimately play. A little puzzle of what multiplies to make the last number, but also adds to make this middle number. And there you go. All right, I'm going to go ahead and stop recording.